and between two particles. And we might look at one of your homework problems that's on this too in the third installment real quick. So this won't be too long. Anyway, let's go ahead and cut this out. And here we go. So we have, so we talked about, now let's talk about the force. Let's talk about the force. If I can get this just to come up. I mean, I don't know why this is so freaking hard sometimes for me. All right, anyway, so here's basically the formula, which is all fine and good, but this is physics, not algebra. So we need to know what each one of these things are. Right? Now here's the force, the electric force. That's what that Fe. That does not necessarily mean it's a force on an electron. That just means the electric force is equal to KQ1 Q2 over R squared. That looks a heck of a lot like. Do you remember the gravitational force? So this is video 2. This is August 20 for the August 24th. This is video 2. Okay, so we've got, do you remember the gravitational force? The gravitational force was F of gravity is equal, now it's not the 9.8 meters per second squared. That's what it is here on Earth for the most part, ballpark. But in general, you've got the gravitational constant times the mass of one object times the mass of, I mean, even this pen and this computer or my desk have a gravitational attraction to each other. It's not near as strong as the electromagnetic forces. Okay, so Gm m1 over m2. The electric force, Coulomb's law, says the same thing, basically. The electric force is equal to the electric constant, not the gravitational constant, the electric constant, which is equal to the charge on 1 times the charge on 2 divided by R squared. Now, what I'm going to do is I'm going to put absolute value signs, because what we do is we do the magnitude first. We just do the magnitude. And then by the picture, we figure out the direction of the force. Okay? In Physics 250, they mess with the matrix algebra to actually get it right on, but we don't care. And ours works just as well as theirs. So, again, looking at the slides again, notice if this is a positive charge and this is a positive charge, notice the force on 1 caused by 2 will push it this way, and the force on 2 caused by 1, which is what that means it is getting pushed that way because they're both like charges, okay? Because like charges attract each other, scratch that. Opposite charges attract, like charges repel. These are like charges and they repel. And they're forces, so they can be treated as vector sums. Vectors must be added to get the net force. Okay, I'm pretty much keeping you in one-dimensional world, 1D world. All right, I like to do it that way. So let's take a look at one of your homework problems on Coulomb's law, and then because this is all there is to it. And so let's take a look at one of your homework problems on this, and we'll do that in video 3.